Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit number 6, Lesson number 10 on the equations of circles. Now, you've been seeing equations of circles for the past year or so. You looked at them in Common Core Geometry. You didn't see them in Common Core Algebra 1. They were a little bit too complicated at that point. All right? And they probably didn't seem too bad in Common Core Geometry. In fact, today's lesson will be primarily a review, and they're going to help set us up for the following lesson when we look at what's called the locus definition of a parabola. All right, so let's jump right into equations of circles. Now, in order to deal with the equation of circles, we need the distance formula from geometry. So if you recall the distance formula, right, the distance formula, ooh, look, green. Let me switch back to blue. The distance formula just says, hey, if I've got one point here at x1, y1, and I have another point out here at x2, y2, then I can find the distance in between them, the straight line distance, by doing this. Now, even though this formula looks a little bit complicated, keep in mind that all it really is just the Pythagorean theorem, right? Where, let's call this big D. This distance is simply x2 minus x1. This distance is simply y2 minus y1, so we just get, a squared plus b squared equals, in this case, d squared, and then we can take the square root of both sides, so we just get d equals. All right, so the distance formula is actually going to be key in what we do this lesson and in the next lesson. So I hope that you became very comfortable with it in coordinate geometry, especially when you did coordinate geometry proofs. All right. Anyhow, I'm going to clear this out, and then we're going to jump into the equation of a circle. Okay. Now, this is important. Circles, as well as parabolas, we'll get into this tomorrow, have what's known as a locus definition. Locus definition. And for a circle, it's as easy as it gets. A circle is simply a collection of all points that are a set distance or equidistant, all right, away from a given point. That set distance is the radius of the circle, and that set point is its center. All right. So let's take a look at a circle below that has a radius of 5 and a center at the point 4, 2. An arbitrary point on the circle, xy, is shown as marked. Okay. Now, letter A says, using the distance formula, show that the point 7, negative 2 must lie on this circle. Verify graphically. Well, first, let me just show you that it does. Let's do the verify graphically first. So 1, 2, 3, 4, 5, 6, 7, 1, 2. There it is. There's the point 7, negative 2. Now, how do we verify that it lies on there using the distance formula? Well, the whole point of a circle is that these 2 points should be 5 units away from each other. So let's do the distance formula there, okay? It doesn't matter which one's x1, x2, y1, y2, you just got to be consistent. So I'll call this my x1, y1, and I'll call this my x2, y2. So I'll have 7 minus 4, x2 minus x1 squared, plus negative 2 minus 2 squared. So 7 minus 4 is 3 squared. Negative 2 minus 2, watch out, is negative 4 squared. Remember, when we square numbers, they always turn positive. So that negative 4 squared is 16. I get the square root of 25, and that is 5. So because the point 7, negative 2 has a distance of 5 units away from 4, 2, it's got to be on this circle. Now, let's come up with a distance formula for all points on the circle. It says, let x2, y2 be x, y. Now, I know that's kind of funny, but all I'm saying is, let this arbitrary point, this guy right here, let that be x2, y2. Okay? And then we're going to keep the center as x1, y1. So what do we know? Well, for any point on this circle, if I take this and I subtract this and square it, and then I take this and I subtract this and I square it, I've got to be equal to 5, right? This is true of every point that lies on this circle. One could then argue that's a good equation for this circle. I actually like that equation for this circle, but it's not the typical way, that we represent the equation of a circle, because what we typically do then is we square both sides. This is letter C. And when we square a square root, it's just going to get rid of it, right? Those are opposites. Square roots are inverses. Square roots and squaring. So if we square both sides, right, it'll get rid of the square root over there, and it'll just give us 25 over there. And there is the equation of your circle in standard form. Now letter D says, show algebraically that the point 1, -2 must also lie on this circle. Well, we could go back to the distance formula, but more importantly, if a point lies on a particular curve, then it must make that equation true. So let's take a look. Let's put 1 in there for x. Let's put -2 in there for y, and let's see if this is true. Well, 1 minus 4 is -3. We already saw this one today. -2 minus 2 is -4. Right? Still don't know. -3 squared is 9. -4 squared is 16. And 25 equals 25. So since that's true, the point must lie on that equation. That's what it means for a point to lie on the graph of a curve. Whether it's a circle, a parabola, a line, it doesn't matter. It makes that equation true. It satisfies that equation. Okay? So pause now, and then we'll look at the general form for the equation of a circle. Okay, let me clear out the text. Let's look at that general form. All right, the equation of a circle. X minus h squared plus y minus k squared equals r squared, where h and k are the circle's center, excuse me, and r is the circle's radius. Again, all this really is the distance formula after being squared, which then means it's the Pythagorean theorem, but it's just really the Pythagorean theorem, using a generic point xy, and using the center, h comma k, and the length of the hypotenuse, which is r. Okay? So, how about exercise number 2? Which of the following equations would have a center of -3, 6 and a radius of 3? Pause the video now and see how much you get this. All right. Well, being extremely mechanical about it, let's take a look. My formula above says I should have x minus -3 plus y minus 6 squared equals 3 squared. So that should be x plus 3 quantity squared plus y minus 6 quantity squared equals 9. And that's choice 2. All right, great. Pause the video now and write down anything you need to, and then we're going to just do a bunch of circle problems. They'll be real quick. We'll bang through them. All right, let's clear out the text. Students generally like equations of circles because they're very easy. In fact, in this problem, exercise number 3, I've got 9 of them, and we're going to go through these amazingly fast. Okay, it says, for each of the following equations of circles, determine both the circle's center and its radius. If its radius is not an integer, express it in decimal form rounded to the nearest tenth. So let's do a few of these together, and I'm not going to necessarily even go in order. So for instance, this particular equation, right? I can tell very easily that the center is at 2, 7 because I subtract off the coordinates of the center. The radius squared is equal to 100, which means the radius must be 10. That's it. Now let's take a look at letter B, because this one's just a bit different. The center is at 5, must be -8, right? It's always going to be x or y minus something. So if we see an addition there, we must have subtracted off a negative. Now a lot of students just learn, I look inside of the parentheses, I take the opposite of what I see. Kind of like the zero product law, kind of like horizontal shifting, right? Horizontal shifting. Except now it works for both horizontal and vertical. Now the radius squared, that's still easy, is equal to 4. Whoops. So the radius is equal to 2. All right, let's look at one more of them, and I'm going to skip all the way down to letter F, which is weird. But in this case, right, the center, right, x plus 6 must be x minus negative 6, so negative 6 and then positive 5. But now the square of my radius is 18, so my radius is now going to be an irrational number. It's going to be the square root of 18. Now if I work that out, right, on my calculator, what I find is 4.24, etc., which to the nearest, what they say, tenth would be 4.2. All right, well, why don't you go ahead and try to finish up the rest of them? They should be very fast, so pause the video and take about, I don't know, 5 minutes maybe to finish these up. Okay, well, let's take a look. Now, letter C is a very, very important one because it's got a center at the origin, right? There's been nothing subtracted from the x and the y, nothing at all. So I just want to get rid of these. They're going to get in my space. The radius squared is 121, and when we take the square root of that, we get 11. So that's a circle centered at the origin with a radius of 11. All right. This one's kind of neat. It's got a center at -1, -2. The square of the radius is 1, so the radius is actually 1. Simple enough. Here, this one's like a combination. We've had no shifting in the x direction, so its center is at 0. But in the y direction, the center is at 3. So the center here is at 0, 3. The square of the radius is 49. So the radius is 7. All right, we're just kind of moving along on these. This one, we go back to one where the center is at the origin, and the radius squared is 64, so that's a nice one. The radius is 8. Here, the center is nice. It's at 4, 2. The radius is not as nice. It's the square root of 20, which to the nearest tenth is 4.5. And same here. The center, very nice, 0, 0. The radius, though, is the square root of 57. Sorry about that. I don't have my notes sitting right in front of me, but we can do this pretty quickly. 7.5. All right. So you want to be able to take equations of circles and very quickly do a few things. Number one, perhaps most importantly, you want to recognize that it's the equation of a circle. Number two, you want to be able to identify its center. And number three, you want to be able to figure out what its radius is. All right, pause the video now and write down anything you need to. Okay, let me clear out the text. All right, this one's kind of cool. It says, write equations for circles A and B shown below. Show how you arrive at your answers. So there's kind of two things we do, right? We take graphs and we create equations, and we take equations and we create graphs. This is one where we're going to take graphs and come up with equations. So let's take a look at circle A. Then maybe you can work on circle B. For circle A, what do we know? We know its center is at 4, 1, and we also know that the point 64 lies on the circle. So I can certainly say the following, right? I can certainly say that its equation looks like this. What I don't know yet is this. But the beautiful thing is we're going to use a trick that we've used many times before, which is we're going to take a point that we know lies on this circle, and we're going to substitute it in to figure out the value that we're missing. So let's take a look at that. Let me put the 6 in for the x. Let me put the 4 in for the y. 6 minus 4 is 2. 4 minus 1 is 3. Let's see, we have 4 plus 9 equals r squared. and r squared is 13. Now, you can certainly take the square root of both sides and get r equals root 13, but you know what? I don't actually need that. What I need is r squared, right? That's what I need. I need r squared right here, and it's 13. So at the end of the day, I can say the equation for circle A is x minus 4 squared plus y minus 1 squared equals 13. That's circle A. Now finding the equation of circle B will be nearly identical. So pause the video now and give it a try. Okay, let's go through it. Just like before, let me lay it out. I can say, well, I've got x plus 2 squared plus y minus 4 squared equals r squared. The only thing I don't know is the r squared. So I'm going to take that point 1 comma 8. I'm going to put 1 in for x. I'm going to put 8 in for y. All right, that's going to be 3 squared, which is 9. That's going to be 4 squared, which is 16. All right, and then we get 25 equals r squared. And again, you can make that r equals 5, or just use this. Because if we just use that, whoops, well, I guess I can't put it there. I'll just rewrite it all. I can get x plus 2 squared plus y minus 4 squared is equal to 25. That's it. So it's actually pretty easy to come up with the equation of a circle if we know where its center is and we know one point that lies on it. All right, pause the video now and write down anything you need to. Okay, let's do a last little piece. Now in our last exercise, what we're going to do is we're going to take a circle that is not written in standard form and change it into one where it is so that we can determine the center and the radius. Take a look at this thing. X squared plus 10x plus y squared minus 2y equals 10. What we're going to do is we're going to put it in this kind of form. We want to write it like that. So let's take this and let's complete the square. How would we do that? Well, we take half of 10, right, which is 5. We add it on and we'll get 25. Now normally I would put minus 25 here. But because this is an equation, what I'm going to do is I'm just going to balance the scales. And by that I mean, since I added 25 onto this side, I'm going to add 25 onto that side. That's okay. That's the additive property of equality. Now on this one, we're going to take negative 2, right? We're going to divide by 2, get negative 1 squared, and we'll get positive 1. Again, because I added 1 there, I'm going to add 1 there. Now, if I've done everything right, these two trinomials are perfect squares. And they are. That's x plus 5 squared. That's y minus 1 squared. And that's 36. Now look at that. That's something I can do something with. Its center is at what? Negative 5, positive 1. Right? 5 to the left, 1 up. And its radius squared is 36. So its radius is 6. And that's it. Right? But it did take completing the square twice, which isn't that hard, especially because the leading coefficients were equal to 1. All right, pause the video on this one, write down anything you need to. All right, let's clear out the text. And let's finish it up. So today, we reviewed probably a lot of material that you felt pretty comfortable with from Common Core geometry. So I apologize if some of this was kind of slow and boring for you. It's really to set us up for the next lesson, where we work with the locus definition of parabolas, and that is new and quite challenging. For now, I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.